Okay, guys. So let's get started without any further ado. In today's class, we're supposed to be going with a few more options left out in Nmap, and these are called the firewall bypassing options, guys. So basically, if your firewalls are configured in the wrong way, you can bypass them by using certain options in Nmap. And depending on what they're configured in the wrong way, we can bypass it. Okay, so there are ways to bypass a firewall on the packet size, on the packet's IP address, on the packet's port number. So we'll learn those few left out options today. Okay. So again, before we get into these options, as mentioned, a firewall is a packet filtration tool. So it allows or blocks packets reaching a certain system depending on the packet's properties. Okay. And if your packet is following certain properties that are mentioned by the firewall, it can allow, again, it can bypass it and get access to the internal data, right? So first option that we're going to learn today is the fragmentation option. Now, this is an option which is used to break packets into small 8-byte sized values. Okay. So basically, sometimes firewalls have rules where they can block packets above a certain size limit. Okay. And by default, your Nmap sends packets which are at a size of 58 bytes. Okay. Now, let's say if a firewall exists which breaks, which blocks all packets above the size limit, let's say 40 bytes or 50 bytes or so, then your Nmap packets will definitely never reach the server. Okay, because they get blocked by the firewall. So what you can now do is you can break the 58 byte size packets into smaller values. Okay, 8-bit sized each. Okay. Now, when the packet is 8-byte size, and if it is below the limit of the firewall, this can bypass the firewall and get access to the internal data. So to fragment your packets or break your packets into small 8-byte sized packets, we have the -F option for that. So to run this practically, I can come back to my terminal here. So my Kali is running on the IP of 192.168.0.7, which is in the same network as my Metasploitable. So that's running on 192.168.0.2, I suppose. As you can see, the device is active. So if I want to run the fragmentation option on that, I can type nmap -s capitalist for synscan -lowercase f for fragmentation and the target IP. Please note, capital F is for fast scan to scan only 100 ports, and lowercase f is for fragmentation. So again, case matters in Linux, guys. So uppercase and lowercase, same alphabet, is again for different operations. Okay. So the lowercase f option, it fragments the packets and gives you the results here. Now, in this scenario here, I'm unable to show you the fragmented packets, but in the upcoming sessions, when we work with a tool called Wireshark, in that class, I can show you how these packets are being fragmented. What is the packet size? Okay. What are these SYN flags? What are these SYNACT flags? How is Nmap performing the scan? I can show you the TCP three-way handshake, all that. Okay. But for now, when we use the fragmentation option, you have to remember these packets are now being broken into small 8-byte sized packets. Okay. That's the main purpose of fragmentation. Now, if you don't want to break it into exactly 8-byte size packets, firewalls can block packets of such a low size as well. In such a scenario, you can set the packet size to your value. Okay. So again, there's an option called -MTU where you can specify exactly what the size of the packet should be. But with MTU, it should always be a multiple of 8 bytes. Okay. So it can either be 8 or 16 or 24 or 32 or 40, but it should always be a multiple of 8. Okay, so if I want to set the packet size with MTU, this is the syntax for it. Nmap scan type -MTU, which stands for maximum transferable unit. And now you can give the packet size here, let's say 24. And now when I give the IP, it starts sending packets for scan with that exact size. And you can see I get the same exact results, no difference in the results. So the only difference you would see is once you analyze the packet and check the packet size, that can be obtained in Wireshark output. Okay, but for now, you just remember what this does. Okay, moving forward, if you don't want to give a multiple of 8, if you want to give it any random number, then there's another option called data length. So this data length option allows you to append the existing size or increase the existing size by a certain value of your choice. And it can be any number. So to the existing 58-byte size packet, you can add a value of buffer data to it with the append data option. Okay, so the option for that is data length. So if I type nmap scan type -data -length, and if I specify, let's say 10, now what this does is to the existing 58-byte packet size, it adds 10 bytes of random data, okay, or buffer data. So now the packet size becomes 68. Okay, so this is to randomize the packet size and not make it a multiple of 8. Okay, so now if I give the target IP, it performs a scan in the same way. So if you notice, all the end results are pretty same. The only difference is in the internal packet size to give you the results. Okay. So this is all about bypassing firewall on packet size rules. Okay. Breaking it down into small 8-byte size packets or breaking it into multiples of 8 or non-multiples of 8. Okay. Now sometimes packets can be blocked on the IP address as well. Okay. And for that, you can spoof the IP with the decoy option, -D. So used to spoof Nmap scan by using one or more decoy IPs. Okay. Now, whenever you mention a decoy IP, it's very important that that IP is active, guys. So if I type nmap ping scan, and if I give the entire network 1-255, it scans the entire network and tells you what devices are active in your network. And once they are active, you can type nmap scan type, and you can specify -D for decoy. And now whatever other IPs are there in your network, you can use them for decoys. So 0.2 is my target. So other IPs in the sense 0.1 can be used for decoy, 4 can be used for decoy, 5 can be used for decoy. Last IP is anyhow Kali systems IP. We cannot use that, okay? Because we want to spoof this IP, okay? So to mention the decoy IPs, I'll mention them here with a comma. 0.1, comma, 192.168.0.4, comma, 192.168.0.5. So these three IPs now will be used to decoy and send packets to the target 0.2. Okay. So again, whenever decoys are mentioned, they're mentioned with a comma. That's an important point to note. And whenever you mention the target IP, that's mentioned with a space. Okay. So nmap, scan type, decoy, and the decoy IP is here with the comma, space, the target over here. Okay. And now when you hit enter, oh, sorry. Yeah. So now when you hit enter, it performs a scan and gives the results by using one of the decoy IPs. Again, we don't exactly know which decoy it is using here. We would have to use Wireshark for that again. Okay. This is to spoof your IP address, guys. Similarly, to spoof your port number, there's an option called -source port. So by default, sometimes your dynamic ports might get blocked from sending packets to the target, and target might accept only well-known ports. In such a scenario, you can spoof the port number to a well-known port with the -source port option. Or there's a shortcut as well. You can use -G, okay, which can be used exactly as -source. Anything works. Okay. So if I type nmap, let's say a scan type, and then an IP target IP. And if I want to spoof the port number, I can type -source -port and the port number. So we can give port numbers like 23 or 53 or 80, any well-known port which might be whitelisted in the firewall. Okay, so now when you hit enter, it performs a scan from your system from that exact port number. Okay, so it spoofs the source port with the -source port option. If you don't want to use this option, you can always go for -G as well. That works the same way. Okay. So these are all the scan types that we were left with, guys, in the last session. Again, I think we have completed all the other scan options in the last class. We covered -P for ports to specify. We covered -IL to give an input list of IPs. Then we excluded a range of IPs with -exclude. Then we excluded IPs from a file as well with -exclude file. And then we excluded ports as well. So quick recap, guys, on all the options we have learned until now. Again, as mentioned, quite important to remember, guys, because these are the same options used in real time. And a lot of questions are asked in interviews as well from these options. Okay. Uppercase O for OS enumeration, getting OS details. Lowercase o for output file to export the output of any command to a certain file of your choice. V for verbose to give you a detailed output of what is happening in the background. Capital F or uppercase F for fast scan, only scanning 100 important ports. T for timing mode to increase or decrease the speed of the packet, okay, or the delay between each packet sent. Trace route to give you the list of all hops from your system to the target server. Script to give, again, to perform script selection and select some of the most important scripts available from Nmap's search engine or Nmap's folder. I think I did give you an assignment yesterday. Did anyone find out some important scripts which are available in Nmap? Did anyone do some research about that? Okay, no worries, guys. But again, whenever time permits over the weekend also, please try to do some research and figure out if there are some important scripts in Enma from that same folder which I've shown you earlier. Okay. And then there's hyphen. So yeah, after script, there's hyphen A for aggressive scan. What does this do? This performs all three operations at once: operating system detection, trace route, and script selection. Okay. So this hyphen A is actually equal to hyphen capital O, hyphen trace route, and hyphen script. Okay. Then there's fragmentation, which we learned today, to break your packets of Nmap into small 8-byte size packets. By default, they are 58 bytes. Okay. So that 58-byte packet is broken down in smaller values, okay, to bypass a firewall. If you don't want to break it down into 8-byte size packets, you can specify the length as well with hyphen MTU or data length. Okay. Decoy is to spoof the source IP. Hyphen source port is to spoof the port number. Hyphen P is to specify the port numbers, what ports you want to specifically scan. Hyphen IL is for input list. List again is supplying a list of IPs through a file. Hyphen FN exclude to exclude a set of IPs. Hyphen exclude file to exclude a set of IPs from a file. And hyphen FN exclude port to exclude certain port numbers from scan. These are all the options we have covered in the last 3 days. Okay. Any questions, any doubts? Anything you want me to repeat again out of Nmap? I think I didn't send the recording for last class, guys. I'll be sharing it with today's session. I couldn't share the file. So I'll be sharing that today anyhow. But in the meanwhile, any questions? Charles, Ben, Wahab, Wamsi? Okay, guys. Cool. So this concludes the entire scanning phase as well. So we are done with the first two modules of cybersecurity. Now comes the next module, which is gaining access. As mentioned, attacking all the systems on the information that you have found in the earlier phases. And the first topic we learn is system hacking, guys. So from here on, there are no more presentation slides, guys, because classes are going to be much more practical from here on. So there's nothing more to much to note down. It's all about you performing practicals. Okay. So the next topic we're going to learn is system hacking in the next session, okay, which is basically how to perform malware attacks. Okay. But before we exit the session, a quick introduction on what malwares are. Malwares come from two words: malicious softwares. Any software which is capable of performing a task other than what it was intended to maliciously harm the system, is called as a malware. And depending on what operation it performs, we have various categories of malwares. There's viruses, there's worms, there's Trojan, there's ransomware, adware, spyware, whatnot. Okay. And each of these malwares has its own unique functionality or specialty, I can say. Okay. Each of these is used to perform a certain task on the system, and all of those tasks will definitely harm your system. Okay, will try to corrupt your system. So those, again, applications which can harm your device and have malicious actions on it are called as malwares. So in the upcoming sessions, we'll practically learn what viruses are, what Trojans are, how do you attack these your systems with these malwares, okay, how do you defend your system as well from these different malwares. So I'll be sharing this notes to you as well, guys, in the class today itself. If time permits, just go through these definitions and try to do some research on this. I'm going to end the session a bit early today. I'm a bit sick, terrible sore throat, so unable to speak much. Okay. But yeah, in the next class, we're going to start fresh on malware attacks. How do you perform malware attacks and what are these different categories of malwares? Okay. Nothing further for today's class, guys. So we have concluded on scanning in today's session. In the next session, we start with gaining access. First attack we'll learn is malware attacks. Okay. Any questions, any doubts up to this point before we exit the session today? Ben, Charles, Vamsi, Wahab. I will, Charles. Right away. I'm going to share the notes and the recordings for last class and today's. Sure, Charles. I understand. I'll share them today right away. Um, any other questions, guys? Wahab, any questions? Ben, any questions? Vamsi. Okay. Assuming no questions, I'm going to share these notes and the recordings for today's class and the last class right away. Bye-bye. Have a good weekend. I'll see you on Monday again. Well, on Monday, we take a slightly longer session because I've taken a shorter one today where we talk about malwares. Okay. Bye-bye. Good weekend, guys. Take care.
Mm.